Field Testing Part 2, Forensic Evaluation. In this course, you will learn about the forensic water leakage evaluation of windows, doors, and skylights, as well as curtain walls, storefronts, and sloped glazing systems. Building damage caused by uncontrolled water penetration through exterior walls is a serious concern of owners, contractors, architects, and product manufacturers. Often, improper or inadequate leak investigations result in investigators misidentifying the source of water penetration through the exterior wall. In many cases, this error results from observations of water penetration at or near a fenestration product opening that may actually originate from the surrounding construction. In other cases, the water penetration is from a combination of sources, which may be inclusive of the fenestration product assemblies. A systematic forensic investigation of the water penetration is required to determine the actual source of the leak. Diagnostic testing is an integral part of the systematic investigation. However, this type of testing differs significantly from other AMA testing documents. The purpose of diagnostic testing is to recreate water leaks that are known to occur. AMA 511 describes the procedure necessary for a systematic forensic investigation. AMA 511 is a complementary document to ASTM E2128, allowing for the adaptation of testing procedures, such as AMA 502. On the other hand, AMA 502 and AMA 503 field testing procedures are intended for evaluating newly installed fenestration products or to provide evidence of compliance with a project specification. Forensic evaluation involves more than just testing. Unfortunately, testing tends to be the starting point for most forensic investigations, though pre-test inspection and data gathering are required. AMA 511 starts with pre-test inspection and data gathering, which will help define the type of testing that will most effectively recreate the water leaks that are known to occur. AMA 511 testing either follows up on AMA 502 or 503 testing, or is used in a water intrusion investigation. Too often, improper forensic water tests create new leaks that have nothing to do with the reported leaks. The next several slides outline common decisions that dictate whether or not you reproduce leaks or create new ones. There could be other objectives for forensic water testing, especially in construction defect claims, which are not covered in this presentation. AMA 511 outlines a prescriptive procedure for a proper forensic evaluation for water penetration. It offers 4 preliminary steps before testing, as well as 3 steps during and after testing, including analysis and report. A forensic evaluation should begin with a review of all project documents. Examples of these types of documents include architectural drawings, structural drawings, shop drawings, installation instructions, contracts, purchase orders, specifications, and warranties. Next is the evaluation of the design concept to identify how the project specifications incorporated water management. These types of documents and details include water management concept, critical details, test reports, flashing, sealants, and weep holes. Then there is a determination of the service history through record reviews and interviews of knowledgeable personnel. To perform an effective inspection, qualified inspectors and investigators must have knowledge of basic physics, construction, and wall design principles and practices in order to observe the interior and exterior, as well as the workmanship and product efficiency, in order to develop a hypothesis for the source of the water intrusion. Click the button to learn more. Fenestration products are designed to resist a specific wind-driven rain pressure. Test pressures and excessive design water resistance pressure will most likely lead to leaks and could lead to false conclusions. The objective of investigative testing is to recreate the known leak. In this picture, it is apparent that water damage has occurred below the window, but it is not known if the source of the leakage is the window or the wall. When performing a test, duration is not the only criteria that requires judgment. Water test pressure often requires judgment as well. All of these factors are important for establishing test pressures, including field standards, laboratory standards, prior testing, weather data, and experience. To simulate the weather events that produce the water penetration, first determine the number of leaks for a given period. Record exact dates, if possible, and obtain weather data from a nationally recognized weather data service. Then match the leak event records with weather data. Note that leakage may not be wind-related and may not require a pressure test. Wind speed data that coincide with measurable rain events greater than 1/100th of an inch, obtained from Weather Service data, should be used to approximate the actual wind-driven rain pressure. If calculated wind speed based on weather data is greater than 2/3 of the rated water test pressure, WTP, for the product, it may be that the product was not the most appropriate for the project. At least one pressure difference test must be done at the 2/3 pressure. The product's water penetration performance value may not be known, but weather data is almost always obtainable. A concerted effort should be made to obtain both the product's rated pressures and pressures created by past precipitation events. Though easily obtainable, weather data is not an exact representation of what the site actually experienced, but it is the most valuable in fulfilling our objective of recreating leaks. ASCE 7 allows us to take the weather data obtained and apply factors that account for specimen height, exposure, and location within the facade. These factors are critical in determining what the specimen experienced during the precipitation event. Even though this is a good maximum test pressure, one must consider whether or not to test to this pressure. Based on experience and training, the investigator needs to recreate the leak in order to resolve the problem. Decisions include how to apply the water, how long to run the test, whether or not to use differential air pressure in addition to water application, and whether to use dynamic or static pressure. The nozzle used for AMA 501.2 testing can be used without differential air pressure as a tool to precisely locate a leak previously identified. Building personnel can often provide valuable information, such as how long it takes for the leak to appear after it starts to rain. Test methods included in AMA 511 can isolate the building facade and the fenestration perimeter sealant joint from the glazing or window itself. If a leak appears during this test and the isolation is adequate, then the window system is not the source of the leak. These procedures are good practice for forensic field water testing. There are always exceptions, but in general, following these guidelines will yield better test data. Start testing at lower elevations and work higher. Start with a zero pressure differential. Step pressures up from zero appropriately. Introduce one new element at a time into each new water test. Use isolation to protect features from water spray. Do not turn the water off at the first moment a leak appears. Try to trace the leak from the exterior to the interior and use destructive wall probes as required to identify this leak path. And do not end non-leaking tests until you are confident the specimen is not contributing to leakage. When testing identifies that the source of a leak is due to a defective fenestration product, the optional sill dam test can be used. This test is not to be used as a sole criteria to determine whether or not the fenestration product is defective. These obstacles are common with field water testing, and it is not uncommon to encounter more than one of the following problems on the same test. No or limited leak history. Leak reported as window leak when leak is actually from another source. Not enough water pressure. Not able to achieve the differential pressure. Owner does not want to remove interior finishes. No or limited access to concealed wall areas. Inclement weather and isolation failures. Click each button to learn more. Brick cavity walls are best tested using exterior chambers. It is important to identify how to apply water pressure either with static pressure on the interior or exterior or with dynamic pressures. Brick cavity walls should not be tested with understatic pressure applied to the interior of the specimen. One of the biggest obstacles is multiple leaks. In addition to multiple leaks, there can be multiple sources for one leak location. Ensure that all possible sources have been identified. Optical borescopes are ideal for viewing the interior of cavities without significant damages to wall finishes. Sometimes the only way to see what is going on is to open up a section of the wall. Infrared cameras can also be used for viewing into wall cavities without removing finishes. Once testing is complete, The forensic investigator has the responsibility to make every attempt to ascertain the exact path of water intrusion. Conclusions are formed in this step on the basis of the inspection and testing data collected in the previous steps. It is very important to note that if conclusions cannot be fully supported by sound scientific principles, then additional investigation is needed. The final step in the forensic evaluation is the report. All reports must be self-contained documents. That is, the factual basis for the findings and conclusions are expressed in the document. The report must include justification for deviations from the methodology described in the standard and must not include any unsubstantiated opinions or conclusions. If results are not conclusive, the forensic investigator should present options for obtaining conclusive results, such as a new testing protocol or procedure. Additional survey work may be required. Drag and drop each numbered step on the left to its description. Click Submit to continue. Congratulations! You've now learned about the forensic water leakage evaluation of windows, doors, and skylights, as well as curtain walls, storefronts, and sloped glazing systems.